Okay, so, folks, sum and difference and double angle identity. So take a look at that first statement. Sine of A plus B. Okay, so if you think distributive property, you might think that that is true. But we haven't done anything by adding angles. And then, like, we haven't looked at this before. So the best way to check is to take two angles and evaluate it, right? So let's take this and we're going to verify this. Left side and right side. So sine of pi over 3 plus pi over 6, is it going to be equal to sine of pi over 3 plus sine of pi over 6? So this we do inside the brackets first, and then take the sine. The other side, we take the sine of each angle. So you can't forget about your trig ratios of special angles in this part of trig, part 2. You've got to know those special angles and what the ratios are. Cannot forget about them. Okay, so sine of pi over, when you add pi over 3 plus pi over 6, you get 3 pi over 6, which is pi over 2. Sine of pi over 2 is 1. Then sine of pi over 3. So remember that's the big angle, right? So the biggest side is 3 over 2. Sine of pi over 6, that's the small angle, so that's 1/2. You already have a common denominator, so you can show it as 1 fraction, but obviously it's not equal to 1. The left side is not equal to right side. So based on this, okay, you might not have known before, so you might just put a question mark there, but now we found an example, right? And remember back to proofs, if we had one counterexample, then we could not say that that statement was true, right, for all values. So, what are we going to do for it? Well, if you take a look at the chart, that is, notice how here on my Smart Notebook file, it has capital A plus capital B, and you have alpha plus beta, okay? Just meaning two different angles. It used to be on the formula sheet that they used capital A and capital B, then they changed it to alpha and beta. So just be aware, it's just two different angles. Okay, so here we have your sum identities, okay, your difference identities for sine, cos, and tan. You don't obviously have to memorize them, but I do suggest you kind of memorize them a little bit if you can. Because sometimes students will partially memorize them or not and look at it and copy it out wrong. That is, again, you gotta have good attention to detail. So let's take a look at the sine sum identity. Sine of A plus B, take a look at it. It's sine A cos B. So these are the different angles, plus cos A sine B. So basically, you have sine and cos of each angle, and you switch them around. Some textbooks might show it as sine B cos A. Order and multiplying doesn't matter. But just be aware that you're taking sine of A here, sine of B here. Cos of B here, cos of A here. So one of these, right? So that's a plus, this is a plus. Take a look at the subtraction, the difference identities. Sine A cos B, cos A sine B, but now it's a subtraction. So this is a subtraction, this is. Again, you don't have to memorize it. Back in the day, I had to memorize it. So I always remember this matches. Okay? And in my head, I go sine, cos, sine. Okay? Cos A plus B, take a look. It's cos A, cos B, sine A, sine B. So both the same trig ratio. Cos first. And then this is a plus, this is the opposite of sine. SIG. Cos A minus B, cos, sine, but the opposite to what was given there. Tan, these ones I don't actually have memorized as easily because we didn't have to do them way back when. So just make sure you remember. Same thing kind of as sine, and remember, tan comes from sine, so it kind of makes sense that this plus here goes with the plus here, but it's tan A plus tan B, so there's no other trig ratios in this. And then 1 minus, so this is a plus and this is a minus, the multiplication. Subtracting here, subtracting up here, now opposite sign. Okay, but again, confirm on your formula sheet. There is no excuse for using the wrong formula on these, right? Because you have your formula sheet. Okay, so now we're going to verify using those two values. So here, now our left side. So we did the left side before, right? These are the same angles. That's equal to 1. Now do the right side.
Is there a symbol for like light be equal to?
Not really. Sometimes you put a question mark, but not really. You don't want to put that though, right? You've got to separate your work.
Yeah.
You get marks taken off if you don't.
If you just have like the might be equal and just like do it separately, like you do not have like.
Then why would you put the might be equal? Just put that side equals and that side equals. You don't want to do the chart.
Yeah, I don't like the chart.
Okay, so always check. Sometimes you know the formula, but the angles you mess up. If you get the same ratio for both terms here, probably you entered the angles incorrectly, right? For the whole thing. So the sine has to be, in each of them has to be for the different angles, and the cos for the different angles. Okay, so make sure you put in, substitute it in correctly. Okay, so you can see that that does work. In part 2 there, it says verify 2 more identities with those angles. I'm going to leave that for you to do because it's just verified. Okay. So you do that on your own. And then we'll look at the double angle identities and see where they come from. So question 3 on the right hand side. Okay, so it says use the sum identities to show that sine of 2a, or 2 alpha, I guess, equals 2 sine alpha cos alpha. Okay, so if we take, so sine of 2a, all these alphas, right? actually, I'm just going to do left side and right side. So we're trying to make this equal to this. So 2 alpha. Well, what's alpha plus alpha? 2 alpha. So we're going to show it as the sum of alpha plus alpha, which from our previous identities that we just looked at, that's going to be sine alpha cos alpha. And I'm going to run out of space here. So it's a plus, so we'll be a plus in there of cos alpha sine alpha. Well, order doesn't matter in multiplying, right? Sine, these are the same angles. So this is the same as this. Well, if they're the same, and we've got 2 of them, that's 2 sine alpha cos alpha. This is 2 sine alpha cos. Okay. So that's just where it comes from. Cos. The same for cos. This. Okay, so for the sum of 2 angles in cos, it's cos cos, sine sine. If that's a plus, then it's a minus in between. So cos alpha alpha minus sine alpha sine, which is the same as cos squared alpha minus sine squared alpha. Now that's one of the double angle for cos identities. There's more. We'll talk about that in question 4. Same deal for tan. Add, no, sorry, we're adding, right? So, yeah, so you add the 2 tans together. In the denominator, it will be 1 minus the product of the tans. So those are exactly the same now. So that's 2 tan alpha over 1 minus. Those are the same. So that'll be tan squared alpha. And do not get lazy. Do not show this for tan squared alpha. This really means tan alpha squared, and that is not the same. So if you're squaring tan, the 2 goes after the letter. I know in the calculator, it looks like it might be more like this, but there has to be brackets around it, and that's really calculator notation. It's not proper. It's not mathematical notation, just like we use an asterisk for multiplying. We don't use ID. We got marks taken off. We use that on any of your ID stuff. So make sure you're using proper mathematical forms, so don't show that. So, in terms of that, cos of 2 alpha equals cos squared alpha minus sine squared alpha, how could we show that in terms of just cos alpha, no sine? So take a look back on your formula sheet for some way that you can replace sine squared alpha with something in terms of sine. Nathan? Yeah, exactly. So here, I'll use alpha instead of A. Okay, so sine squared alpha, take a look at your formula sheet. Remember that sine squared plus cos squared, the theta, equals 1. So if you rearrange that, sine squared is 1 minus cos squared alpha. Collect like terms, so get rid of the brackets correctly. Collect like terms, that'll be adding, I'll show that, I guess. So now we get 2 cos squared alpha minus 1. That one I always have to, like, I don't have a formula sheet. I always have to think back. I have in my head cos squared minus sine squared memorized. In terms of having it just in terms of one trig ratio, I kind of do that in my head. I go, oh yeah. So if I want it in terms of cos, I've got to go replace sine with 1 minus cos squared. So then I know it's going to be 2 cos squared minus 1. So then the same for the next one. But here I want it in terms of just sine. So I want to replace cos squared with 1 minus sine squared. And then collecting like terms there, it's going to be 1 minus 2 sine squared alpha. All right. So those are the identities. That's a whole bunch of them. And now down to almost, well, pretty much the whole page now. Just at the bottom there are just your transformation forms. So we've gone through all that are available to you. Okay. Now we're going to do some work with them. So if we look at question 5, it says write each expression as a single trig function. So we're going from something expanded and trying to simplify. Okay? It should actually say in there, show with an exact value, because really, well, it says it's a single trig function, so that, but if we said evaluate, you could just punch that into your calculator, right?
Oh, no, the next question is this exact value.
Yeah. You want, the whole point of these is going to sort of expand your ability to get exact values for more angles. Right now, it's just your special angles plus multiples of those. Now we'll be able to get it exact values for more than just those. Not everyone, but anything that you can add to special angles that add to something or subtract to something or double it, that kind of thing. So it does expand our ability to do that. So a single trig function, we're going to look here. It's 2 terms, which you take a look at your formula sheet. You know that there's a few like that. Take a look. It's cos, cos, sine, sine. So remember when it's coses and sines, it's going to be cos of the 2 angles. Okay. So take a look at that. Just make sure that these 15 and 40 are the same, because otherwise you couldn't simplify it, right? Now, we could, we look here, it's a plus. So remember for cos, that sign is the opposite of that. So this would be, what's that, negative 25. It doesn't say that the angle has to be positive, so that works. Okay. What about if, say this is the same as cos 40 cos 15 plus sine 40 sine 15. If I just rearrange this term, or this factor with this factor, order doesn't matter, right? Then if I used my sum identity, I'd have cos of 40 degrees minus 15, and I'd get cos of 25 degrees. How do we know that those are equal? Like they're different for the same expression there. What do we know about that?
Same reference angle.
Same reference angle, and in the first and the fourth quadrant, cos is positive, right? So that's why both of these are exactly the same. And it would be accepted, either one. If I said in the question that your single trig ratio has to have an angle between 0 and 360, then you would want to rearrange it and do this, okay? Or you could go to here and then show it like this, okay? So just be aware of that. Okay, do the next one. Obviously tan. Look on your formula sheet. Just always make sure that these angles are the same. Otherwise, you might not be able to simplify it, right? But they are. So this is going to be equal to tan of 2 times 20 degrees. Okay, take a look at the formula sheet. It says tan of 2 alpha equals 2 times tan of alpha. 1 minus tan squared alpha. So this is your alpha. You've got to double it. Put it in. Okay, next one, simplify again, and then state the exact value. So, cos squared minus sine squared. Again, look on your formula sheet. Cos squared minus sine squared is cos of 2 alpha. Okay, so this is going to be cos of 2 times 15. Right now, the way it is, I can't get the exact value. I can check it, I can get a decimal form, but now, when I use that double angle identity, it's equal to cos of 30 degrees. Well, cos of 30 degrees is root 3 over 2. Okay, all of these, though, you can check with your calculator, so please do that. It kind of drives me nuts when you have the ability to check, right? So, this is in degrees, low P degrees. Okay, the original question, so that's going to be, so in your calculator, you can square after that bracket, it's squaring all of cos. Or you can put brackets around the whole thing, but you don't actually have to. That minus sine 15, close the bracket, squared. That's the decimal form. Now root 3, divide by 2, you get the same thing. So you know that you've done it correctly. Well, it'll probably be 1 mark, so. I'm just doing so you know where that came from, right? Okay, evaluating this, I don't know what pi over 8 the trig ratios are, right? That's not a special angle. But I look at it, I've got sine, cos, cosine. So I know that that's going to be sine. The angle is pi over 8, 9 pi over 8. So pi over 8, 9 pi over 8. If this is a plus, then a plus goes in there. For sine, it's the same as on here. Okay? That I would though, Adam. In this one, for the sum ones, I would show that separately like that. So then that's 10 pi over 8, which reduces, so that's 10 pi over 8. 5 pi over 4. So remember, 5 pi over 4 is there. So sine is, that's in the third quadrant, so negative. Reference angle is pi over 4. So that's root 2 over 2. Okay. In your calculator, now we're in radians. Okay, so sine of pi divided by 8, close the brackets, times cos 9 pi divided by 8, close the brackets. Oh, start again. Sine pi divided by 8, close brackets, times cos 9 pi divided by 8, close brackets, plus cos pi divided by 8, bracket, sine, okay, and then what I think at the end is negative root 2 over 2. Same thing, okay? Okay, so now says determine the exact value of each of these. So now we're working backwards from what we were just doing. Last couple of questions, we were trying to simplify to a single trig ratio. Now we're going from a single trig ratio back to something expanded that has special angles. So let's leave these. Okay, so 105 is not a special angle, right? So you want to think about, this is in degrees, so you might want to write out your 3 special angles. Obviously there's 90 in there as well, but we cover it anyway. And think about what you could add or subtract. Try to keep it to 2, right? Add or subtract to get 105. So this, for example, is not enough. You do 2 of these and this, but you're not going to add 3 angles together because 2 of these is 60, right? So this 105 is 45 and 60. So I would write this as sine of 45 plus 60. Okay. And then that's the sum. So this is going to be sine cos plus cos sine. Then special angles. Find the trig ratio exact values of all of those. Remember, you don't draw a whole unit circle, right? That's the first quadrant. Get that chart I told you about, however you want to do it. number these will likely say show as a single fraction, reduced fraction with rational denominators. And you can check, find that decimal form, go back to sine of 105 degrees, make sure it's the same decimal. Okay, oftentimes students find the radians a little bit harder to deal with than these. So again, just like I did for degrees, 30, 45, 60, I'm going to do pi over 6, pi over 4, pi over 3. This has a denominator of 12. So I'm going to show these all with a denominator of 12. Really doesn't take you that long to do that. And then you want to look at what we can do there to get pi over 12 when you add or subtract. There are many few choices that you can do, right? So I could go this minus this. I could go this minus this. Okay. Yes, you could all obviously do bigger angles, right, that are bigger than 90 or pi over 2. But why? Keep it as small as possible. So, I'm going to do these, the smallest ones. So, I'm not going to write it out with the denominator of 12. I'm going to show this as pi over 4 minus pi over 6. Okay. So, then for your tan, it's going to be tan pi over 4, tan pi over 6, same sign as inside the brackets. Then it's going to be 1 plus tan pi over 4 times tan pi over 6. So, pi over 4 for tan, remember, is just 1. Pi over 6 will be 1 over root 3. Okay, because it's 1/2 over root 3 over 2. Rationalized would be root 3 over 3. Okay, then you're multiplying. You've already figured those out, right? So it's no new calculations or ratios. Some of you, I think there was kind of one on a test where you had fractions within a fraction. Some of you left it. You never leave a fraction within a fraction. Oh yeah, plus. Sorry, thank you. Never leave a fraction within a fraction. So easiest way, multiply by the lowest common denominator of all fractions in there. So 3 times 1 is 3, minus 3 is 3. That's going to be 3 plus root 3. Okay. Is that in simplest form? No, because there's a irrational in the denominator, so we need to multiply by the conjugate. conjugate of the denominator is 3 minus root 3. Need a little more space on this one. So that's going to be 9 minus 6 root 3. Plus 3 over 9 minus 3. You can check it if you want. Tan of pi over 12 on the decimal form, 2 minus root 3. Decimal forms will be the same. Now, if you still have this, you can use it to help you get 23 pi over 12. So that one is bigger, right, than adding just two angles together. Twenty-three pi over 12. What's 23 over 12 goes to? Goes to 2, right? So you're going to have some bigger angles in there, right? Either one of them being bigger at least. Now you might think, oh, I could go 2 pi minus pi over 12, but then pi over 12 is still not a special angle, right? So take a look at these. Multiples of these will be special angles. So how about 20 pi over 12 plus 3 pi over 12? Right, that would be 23 pi over 12. So 20 pi over 12 would be 5 pi over 3. That would be 1. Yep.
I mean, well, we already figured out, like, we already figured out a way to do that, so you just do that and then do times 2. So you have to evaluate one of them first, and then you can just.
This times 2?
Oh, no, sorry, not times 2, and then add it to, or subtract it from, like, so you can't divide.
Yeah, that's 10. That's kind of confusing. You want to pretend it's a fresh question. So if it's a fresh question, you haven't done any other work, no, there's more than one choice. I'd probably go take 5 pi over 3, that's going to be 20 pi over 12, and add 3 pi over 12, which is pi over 3. So this
Instead of pi over 4 minus pi over 6, you did like pi over 3 minus pi over 4. And no.
pi over 3 minus pi over 4, yeah. Work at the end. Yep. Simplify it to the end. Okay, remember secant is 1 over cos, so this is going to be cos. Okay, so what you might want to do is do the cos work on the side, right? Or you can put it all in there if you want, I guess. If we do, we would then have here cos minus sine work on that. Okay, so then write it down to a fraction, but it's not rational in the denominator. So again, rationalize it. You wonder why we did all this with the radicals last year, right?
Wait, hold on. Why is sine of pi over 4 is not negative 2 pi over 2? Or pi over 2? Whatever.
Oh,
It's
correct.
negative.
It's positive.
Yeah, positive.
Thank you. Now, remember when you rationalize, you need to expand the brackets out, but I'm going to leave it in factored form because if you take a look at this, when you multiply these conjugates, you're going to get 2 minus 6, right? Which is negative 4, which that's going to divide out. So why expand and then have this factor again? I'm going to leave it. And then divide the negative in, so that would be, actually I'll put the positive term first. It doesn't matter which term you put first. Adam? Sorry? No, opposite signs here. So this is a positive divided by negative is a negative. Negative divided by negative is a positive.
Oh.
I changed the order to put the positive term first. Okay, question 8. Given the ratios for certain angles, we then need to find the value of a trig ratio, either a double angle or a sum. So this kind of goes back to one of the first lessons of trig, but also now obviously these identities. This is a very, I've seen this type of question on the phone exams. So, heads up. Okay? So, cos theta is equal to negative 3/4. Sine of beta, so those are two different angles. Just remember that. It gives you what theta has to be. It has to be between pi and 3 pi over 2. Beta has to be between 3 pi over 2 and 2 pi. Determine the exact value of the cos of 2 theta. So notice how this has no beta in it, so we're not even going to care about that. So cos of 2 theta, we have a few choices. There are 3 trig identities for cos of 2 times an angle. If we know the value of cos of a single angle, then remember, take a look at the identity that has just the cos of a single angle. All right. So this one doesn't really require too much work. Cos of 2 theta will be equal to 2 cos squared theta minus 1. And we know cos of theta is negative 3/4. So really it's just substitution. So sometimes students will go from here, they'll use their calculator, get a decimal form of the angle, double it, and get a ratio. Sometimes it might work out to be an exact value, but sometimes it won't. So use your identities to make sure that you will get it exact. Because in this case it would. So 2 times 9/16 is 9/8. So for cotan, yeah, you could go cos of 2 beta over sine of 2 beta, use 2 identities. I think it's probably faster to do 1 over tan of 2 beta. Okay, so that's going to be 2 tan beta. Okay. So all that we know is this for beta. So sine of beta is negative 1/3, and beta is in the 4th quadrant. Okay, so this would be negative 1 and 3.
Wait, why wouldn't you just do cosine over sine?
I said you can do that. Okay, you have these 2 identities. Okay, so then here, in order to get tan, we do need adjacent. So 3 squared minus 1 squared, that is 9 minus 1 is 8. So this is root 8, which is 2 root 2. Positive, right? Okay, so that's going to be positive 1/8, 1 minus 1/8, so 8, so that's going to be 7/8. Okay, so notice here, I think I've done that correctly. So evaluated, so the -1 squared is +1. 2 root 2 squared is 8. 1 minus 1/8 is 7/8. This is what? 8 over 7, the root 2 stays down there. I'm not going to rationalize this because that's the value of what goes in our denominator there. So then up here, it'll be 1 over -8 over 7 root 2. So then when I simplify that, it'll be -7 root 2 over 8. Let's check that one. Although I guess there's nothing we can check really. Well, yeah. Okay, so this is going to be -7 root 2 divided by 8. Okay. So given our sine, so second sine of 1 over 3 is our reference angle. So then that would be 2 pi minus the reference angle. That would be our angle times 2. Tan of that. And then 1 divided by that. Yeah. Okay. So what I just did there to check. I found my decimal form of the answer. Then I went back up here. I did my second sine of +1 over 3 to get that reference angle. I went 2 pi minus it to get angle beta. I doubled it to get this. Took tan of it to get this, and then 1 divided by that, I got the same answer. So you can't check it, but if you give me a decimal answer, right, without any work there, you're not going to get any marks actually. Okay. You can check the work. Okay, so sine theta plus beta. Sine's not too bad, right? Sine theta, cos theta. So some of these you do know. So you know sine of beta is -1/3 and cos of theta. So here, we don't know this or this, but we know this and this. Okay, so we need to work from the information given to get the ratio for sine of theta and cos of beta. So here, this last question was in terms of beta. So cos, I already figured out the x value there. Cos would be 2 root 2 over 3. So I've already done the work on that. Okay, and then sine of theta. So we know, given cos of theta is -3/4. And what quadrant? That was in the third quadrant. Okay, so cos was -3/4. So 16 minus 9 is 7. This would be -√7. Right, and then sine of that angle is negative that you can reduce the 3's there, but I'm not going to because this has the same denominator. It'll always work out like that. So then we will have what? Negative 2 root 14 plus 3 all over 12. So I'll do this in a fraction. Negative 2 root 14 plus 3 all over 12. Okay. Then finding those angles. So I have to go up. Yeah. So the beta angle, I already calculated that to be 5.94. So, okay, so I'm going to go back to that. And then theta, my reference angle, so second cos 3 divided by 4. So that's my reference angle. It's going to be plus 5. Okay, so that's my cos, or that's my theta. So now I'm going to go sine of that angle plus that one, and you get the same value. Okay, so knowing for special angles, is it important? Yeah, the integrations of special angles, yeah. Okay, it all builds on itself. Okay, last one. So this is question 9. It's separate from the last one. Different values given. So now it is tan of b equals 3 over root 5. Cos of b is negative. And then find the exact value of sine of 2b. B or not b? Okay. So sine of 2b equals 2 sine b cos. So let's think about this. Tan is positive, so that is in the first and third. Cos is negative in the second and third, so it's going to be in the third. Tan is opposite over adjacent. Both will be negative because it's in the third quadrant. So we need, for sine and cos, we need the hypotenuse. So 3 squared is 9, plus 5 is 14, so this will be root 14. That's always positive. So this will be 2 sine of beta, or b, sine will be negative 3 over root 14. Cos is negative root 5 over root 14. So pretty straightforward. Positive 6 root 5 over 14 reduces. Okay, and again, to check, okay, you can go second tan, 3 divided by root 5. Okay, that's the reference angle. This is in the third quadrant, so add pi to that. So that's your beta. Now we want to go 2 sine of that. Close the brackets, cos of that. Okay, then check. Oh my don't do fractions. Mess it up. So 3 root 5 over 7 root 6.